Today, mining gold requires some of the largest machines ever built. Haul trucks taller than a two-story house, open pits visible from space, billion-dollar operations running around the clock. And we still struggle to get to it. So how did ancient civilizations manage? No engines, no steel, no electricity, and still extract enough gold to build empires. Gold doesn't rust, it doesn't corrode. Leave it in a riverbed for 10,000 years, and it looks exactly the same. Sitting at the bottom, dense and glinting. That's where early people found it. It can't be eaten, it can't be used to hunt. But it doesn't decay, it's rare, and it's beautiful. And for societies that needed something everyone agreed was valuable, that was apparently enough. The technique to collect it required almost nothing. Gold is roughly 7 times denser than most river sediment. When water moves, lighter material carries downstream. Gold sinks, collecting in natural pockets, inside bends of rivers, spots where the current slows, spaces behind large rocks. Scoop sediment into a shallow pan, add water, swirl. Lighter material washes over the edge. Gold stays at the bottom. No specialized tools, no digging, no construction. It worked. But the ceiling came fast. Surface gold runs out. Once a riverbed is exhausted, you're done. For civilizations building at serious scale, that limit arrived quickly. That's when they started going into the rock. The ancient Egyptians and Nubians were among the first to pursue gold locked inside solid stone. The Egyptian word for gold was nub, where the name Nubia comes from. For centuries, pharaohs organized large-scale expeditions into Nubian territory and the eastern desert specifically to extract it. Thousands of workers, many of them prisoners of war and enslaved people, were sent into some of the most hostile terrain on Earth. Relentless heat, almost no water. Supply lines existed largely just to keep the workforce alive long enough to mine. The gold wasn't sitting loose. It was locked inside hard quartz rock. Their solution was fire setting. Workers built large fires directly against a rock face, kept them burning for hours, then threw cold water onto the heated stone. The sudden temperature shock cracked the rock along its natural stress lines. Workers chipped away the weakened sections using stone hammers and copper tools, followed the gold-bearing veins deeper into the rock, and repeated. In enclosed tunnels, those fires consumed oxygen and produced carbon monoxide. People died doing this. Once the ore came out, it was broken down further with stone hammers, ground finer on flat grinding stones, then washed with water. Lighter dust carried away, heavier gold-bearing particles left behind. The same density principle as riverbed panning now applied to rock they had fractured themselves. What remained was smelted and cast. By around 1160 BCE, the Egyptians knew their mining regions well enough that someone drew a map. The Turin Papyrus, one of the oldest geological maps ever found, marks specific mine locations, road routes through the desert, and notes on different rock types. They weren't just mining, they were managing a resource across generations. The Romans took a fundamentally different approach. Rather than sending workers into the rock, they moved the rock out of the way entirely. At Las Medulla in northwestern Spain, Roman engineers built an extensive network of aqueducts and tunnels. They redirected river water to the tops of gold-bearing hillsides, held it in large reservoirs, then released it all at once in a sudden, controlled flood. The water didn't wash the surface, it collapsed the hillside. The Romans called this ruina montium, the ruin of the mountains. Pliny the Elder, writing in the 1st century CE, described watching entire slopes give way and compared the effect to an earthquake. The debris was channeled through sluices where gold settled out by density while the waste was carried away. Las Medullas ran for roughly 2 centuries. The landscape it left behind still looks like another planet. jagged, blood-red towers and ravines that nature alone never would have made. The site is a UNESCO World Heritage Site today, not for what was built there, but for the scale of what was permanently erased. From someone kneeling by a river with a pan to Roman engineers redirecting rivers to collapse entire mountains, the scale kept growing, the methods kept changing, and the cost kept rising. Here's something that's hard to fully picture: all the gold ever mined by every civilization throughout human history, stacked together, would fit inside roughly 3.5 Olympic swimming pools. That's it. Every empire, every expedition, every tunnel dug by firelight, every hillside the Romans dissolved, 3.5 swimming pools. Make of that what you will.